Welcome to The Explainer. Today we're digging into a pretty wild idea. What if space-time, one of the biggest ideas in modern physics, is actually built on a simple geometric mistake?
Okay, so let's start with a little thought experiment that's really at the heart of this whole critique. Picture a train, and it's moving at like nearly the speed of light. You snap a picture. Now, in that photo, the floor of the train is at one specific spot. But the ceiling, well, it looks like it's lagging behind, back where the train was a split second ago. So the whole thing looks slanted, distorted, almost broken. The question is that what's really happening?
To get our heads around this puzzle, the source material offers up this really cool idea. They call it observation equals archaeology. Basically, it means that when we see something, we're not actually seeing it as it is right now. We're just receiving the old light that has traveled from its past. In a very real sense, we're archaeologists, digging up old information with our eyes.
We all kind of get this on a huge cosmic scale, right? The light you see from Polaris, the North Star, left that star over 400 years ago. So when you look at it, you're literally seeing it as it was back during the Renaissance. But here's the kicker in this argument. That same principle applies to everything, no matter how close it is. The delay is just way, way shorter.
And this creates this really important difference between the fact of an event, what's actually happening in a single moment, and the observation of it, which is always a delayed collection of light from the past. So what we see in a single instant isn't a snapshot at all. It's more like a collage, a mosaic of different moments in time, all arriving at your eye at the same time.
Okay, so if what we see is this delayed collage, how in the world do we map out what's really going on? Well, this critique argues that you can't do it on a single flat surface. No. To get it right, you need to think in three distinct layers, or planes, and this is where the geometry really kicks in.
So these three layers are, first, the reality plane. This is where the train physically is, where the event is actually happening. Then you've got the observation plane. That's down where we are, where the camera is. And sandwiched right between them is what's called a mathematical plane, which is just an abstract surface, kind of a canvas for doing all the calculations.
Now, the single most important detail here is the separation. In this model, the thing that's happening and the person seeing it aren't in the same place. There's a physical distance separating them. In this example, it's 20 units. And that gap, that number, isn't just a detail. It's the absolute key to this entire argument.
So here's the crucial question. If reality really has this kind of 3D depth to it, where exactly does this critique say that relativity's classic thought experiments went wrong? Well, the author points to one specific mathematical step.
The so-called error is something called orthographic projection. Now, that's a fancy term for a really simple idea. It's what happens when you take a 3D reality and just squash it onto a flat 2D map. Think about trying to make a flat map of the Earth. You can't do it without stretching and distorting things like Greenland, right? Well, the argument is the same thing happened here. By squashing everything down onto that middle mathematical plane, you completely erase that crucial 20-unit separation between the train and the camera. The real diagonal paths that the light traveled through 3D space just get collapsed into straight lines on a 2D drawing. All that vital information about depth, distance, and travel time, poof, it's gone.
At its core, the argument is that early physicists mistook their distorted map for the actual territory. By ignoring that third dimension, the depth between the event and the observer, they were forced to invent some pretty strange rules, like space and time themselves distorting, just to make the weird illusions on their flat picture make sense.
And this, according to the author, leads to something they call a double lie. The first lie, mistaking the optical illusion, that slanted train caused by light delay, for a real thing that's happening in the moment. And the second, deeper lie, inventing these bizarre concepts of warped space and slowed down time just to mathematically fix the problems that the first illusion created. So from this point of view, the universe isn't really bending or twisting at all. Space is just space. Time just ticks along. The weirdness that we talk about with space-time isn't really out there in the cosmos. Instead, this critique argues, it's just a byproduct of a flawed map-making process, a ghost created by ignoring that third dimension of observation.
And that leaves us with one heck of a final question. Is space-time a real, fundamental fabric of our universe, or is it maybe just a ghost in the machine, an illusion we created simply because we drew our maps the wrong way?